Saturn is one of the most well-known planets in the solar system, perhaps owing to its distinctive set of rings. The largest of these rings, the H ring, was only discovered as recently as 2009 and cannot be seen from Earth. Later that year, NASA's WISE spacecraft was launched with the goal of mapping the entire sky. Now, using images taken by this spacecraft, scientists at the University of Maryland have given us the first insights into the structure and formation of Saturn's outermost ring. The answers that they have uncovered could revolutionise how we view our solar system and its ever-changing landscape. I spoke to lead researcher Doug Hamilton to try to remove the shroud around Saturn's most mysterious ring.
We've been able to look at the structure of the ring in these images, and what we've discovered is that the particles are dominated by fairly small dust grains, so 10 microns in size, 1/100 of a millimeter, very, very small.
The rather catchily named H ring was discovered in 2009 by the Spitzer Space Telescope. But what led to its formation?
This one actually seems to come from the satellite Phoebe. And so Phoebe is a distant object of Saturn. It's got a tilted orbit around Saturn, which means it goes up and down. And the height that it goes up and down matches the height of our ring. It tells us that Phoebe is the source of the dust particles.
So how does the material come off Phoebe to actually form this ring?
It's an impact onto Phoebe. There are collisions from other objects out at Phoebe's distance. So think of a comet tail and all the debris that comes off of it. Those bits are hitting the satellites and kicking off debris that form part of the ring. And then where Phoebe is located, there are another 50 small satellites, and occasionally they collide, producing more debris.
The main rings of Saturn are visible from Earth. You can even see them with your own telescope on a clear night. So why can't we see this new ring?
Since the dust particles are black, they're really hard to see with visible light. You've got black dust particles set against the darkness, the blackness of space. So what we do is we realize that those black dust grains will absorb sunlight quite efficiently. They heat up, and then they re-emit in heat. They re-emit infrared light. We use telescopes that are sensitive to that light.
You visualize this using this infrared light. What does it look like on these images?
This is pretty neat as well. So it's fairly planar, so it's flat. So you want to think of a coin, sort of a coin edge on. So it's a flat but yet extended structure. And then we see it just because of how the dynamics of the particles work. We always see this thing edge on from the Earth. So you have your coin, and you flip it on its side, and you're looking at it like that. So what we see on the sky would be a rectangle.
What makes this ring particularly interesting?
It's turned our whole idea of what rings are on its head, because we always hear that rings form close to their parent planets, and then you get moons and satellites further away. And this has just flipped it around. So we're as far away from Saturn as we can get and still be in orbit around the planet. And, there's satellites out there, but there's also a ring. And so this makes us think differently about rings. And so we hopefully will open our minds a bit and learn a bit more about how they form.
The analysis of these new images from the WISE spacecraft has given us greater insight into the structure of Saturn's latest ring. But how does this new ring compare to the others?
So we have the massive rings, which you see on the telescope images. And so those have been known for a long time. Those are composed of big house-sized chunks of ice. And then we have Saturn's E ring. So that's a ring that's bigger than the main rings of Saturn, but it's extremely tenuous, and it's made up only of small dust grains. This large ring that we have at great distances from Saturn is in between. So we have big particles like you find close to Saturn. We have the smaller particles like you would find in Saturn's E ring, and everything in between.
Are there any other applications or any other knowledge you've gained from studying this ring?
We like things that are the biggest and the brightest and the furthest and the strongest and so on. So this is the biggest ring in the solar system. So that's kind of nice, just on a gee whiz sort of level. On a deeper level, what it teaches us is not to be too bound by our expectations. So nobody expected a ring to be this large. And so as we go forth and look at exoplanets, and we're looking in the data for signals, we've been surprised over and over and over with exoplanets. And so back home here in the solar system, we're surprised by this ring. And what it teaches us is just to be open-minded. The universe has a lot of things it can do that hasn't shown us all of its secrets yet.